Welcome to the Benefits of Protein Part 3, Hormones, Neurotransmitters, and the Immune System. I'm Dr. Max McLeod, aka the Nutrition Ninja Doc. I've spent over 40 years helping people to achieve their health, performance, and appearance goals. That experience, plus 2 medical degrees and a doctorate in nutrition, allows me to cut through the BS and help you get the results you're after. In this video, we'll focus on a few more of the amazing benefits of protein. Protein's role in the endocrine system, protein's role in the nervous system, and protein's role in the immune system. Having a deeper understanding of protein will hopefully motivate you to incorporate more high-protein foods, some good protein foods, into your daily diet to get the many health benefits of protein. Protein and health go hand in hand, so if you aren't getting enough, consider the advantage of adding a quality protein powder to supplement your regular diet. Let's take a quick look at what I consider to be the best protein powders on the market. It seems like there are a million protein powders out there. These are my 3 favorites, and yes, I'm biased. I developed them to be the best. I've been eating protein powders for over 40 years, but I wanted something better, something clean, organic, plant-based, balanced, and complete, and something that was real food. These are what I came up with. You really should give them a try. Find them at mybodysymphony.com. Let's get to it, and be sure to watch all the way to the end for some great bonus information and because it really helps with video rankings. Protein has many vital functions in the body, and although our bodies are capable of making thousands of different proteins that perform all kinds of amazing functions, they ultimately rely on the proteins we ingest for the raw materials to do so. Our cells and tissues, the liver in particular, are tiny factories that churn out specialized proteins and related products for all kinds of uses by the body. We can make most amino acids, which are the building blocks and breakdown products of protein, from various other substances, but we're not able to make the essential amino acids, at least not in sufficient amounts to provide for the body's production needs. That's why we need to ingest sufficient quality protein regularly, ideally daily. Beyond the formation of metabolic enzymes, which account for up to 50% of what ingested protein is used for, protein performs numerous vital additional functions. Let's take a closer look at 3 of those in this video. For your information, I discussed the production of metabolic enzymes in the first video of this series. First, hormones. One of the many things that the body uses protein to make are hormones. Hormones perform a wide range of regulatory functions. There are 2 classes of hormones. 1, hormones that are made from amino acids that our bodies either produce or derive from proteins in our diet. Or 2, hormones that are made from cholesterol. These are primarily the sex hormones. Hormones, as part of the endocrine system, are some of the primary regulators of metabolism and health. Our focus today will be on protein hormones. Let's look at some examples. TRH, thyrotropin-releasing hormone, acts on the anterior pituitary gland and signals it to release TSH, thyroid-stimulating hormone, which in turn stimulates the thyroid to produce and release the thyroid hormones T3 and T4, which in turn regulate the metabolic rate of the rest of the body. Here's a diagram of the way the different thyroid hormones interact. TRH from the hypothalamus acts on the anterior pituitary gland, causing it to produce TSH, which acts on the thyroid gland, stimulating it to release the thyroid hormones, mostly as T4, the relatively inactive form. T4 circulates to the tissues where it's converted to T3. As you can see, T3 is much more active. But as you can imagine, there are numerous places where things can go awry. And we're going to do some videos on that in the future. ADH, antidiuretic hormone, also known as vasopressin, is another peptide hormone. It works to regulate extracellular fluid volume via effects on both the kidneys and blood vessels. Next, insulin and growth hormone are 2 more protein hormones. They are the major anabolic or building hormones of the body. LH and FSH, luteinizing hormone and follicle-stimulating hormone, both are intimately involved with the regulation of the ovaries and testes in men and women respectively. This technically puts them in control of the steroid or cholesterol-based hormones as well. Clearly, all these hormonal functions are absolutely vital to life and health. This diagram, although a bit difficult to make out here and read, is simply illustrating the different categories of hormones mentioned earlier. Although there are 4 rows, the first 3 are all essentially protein hormones of increasing complexity. The last row represents the steroid hormones, which are the only non-protein hormones. Next, let's look at the neurotransmitters, the regulators of mood and behavior. Amino acids derived from proteins, of course, are either neurotransmitters themselves or are the precursors of neurotransmitters. Tryptophan, glutamine, histidine, tyrosine, and arginine are examples of amino acids that are precursors to key neurotransmitters, while glutamate, aspartate, and glycine act directly as neurotransmitters. Neurotransmitters are chemical messengers that are produced in and used by the body to enable, enhance, or inhibit neurotransmission. Neurotransmission is simply the transmission or propagation of neuronal activation or firing, an electrochemical process that is the essence of brain and all nerve activity in both the central and peripheral nervous systems. This diagram shows the various categories of neurotransmitters. As you can see, the vast majority, as with hormones, are amino acid or protein based. There have been well over 100 neurotransmitters identified to date, the vast majority of which, 90+%, are composed of amino acids or slightly modified amino acids. Clearly, they impact virtually every aspect of our lives, behaviors, and emotions. This is an artist's representation of a tiny part of the neuronal network. Many billions of neurons make up the nervous system. The nervous system is one of the primary communication systems of the body. It relies on neurotransmitters to function. The immune system and protein. Immune system function depends heavily on proteins to protect us against invading microbes, to fight infections, and to coordinate repair of damaged tissues. Many immune molecules are largely composed of proteins. Antibodies are a major example. Many pathogens, such as microbes, parasites, and even cancer cells, are recognized by the immune surveillance system as non-self. This, in turn, activates the immune system to attack and try to neutralize them. Things that the immune system identifies as non-self are, by definition, antigens. The B cells of the immune system produce antibodies in response to any recognized antigen. Antibodies, also known as immunoglobulins, are composed of proteins which bind to the antigen, either neutralizing it or tagging it for attack by other immune cells. Here's a diagram that depicts the antibody-antigen system of interactions. Again, an antigen is typically a foreign protein which may be part of a virus, bacteria, toxin, or cancer cell that triggers the immune system to produce antibodies. Antibodies are proteins that bind to antigens very specifically. They may damage or kill the antigen directly, or simply tag it to make it easier for other components of the immune system to attack and destroy. Basophils are another type of immune cell. They release histamine, an amino acid that helps to mediate additional immune reactions, including the attraction of two other vital types of white blood cells, neutrophils and eosinophils. This serves to further mobilize and reinforce the immune response. Here's a artist's rendition of a cartoon of a basophil, what they look like. This is an artist's representation of a cancer cell dividing. Although cancer starts out as a normal cell, mutations cause it to turn against us. These mutations often alter some of the surface proteins, thereby allowing the immune system to attack and destroy them. Others, unfortunately, are able to cloak themselves, thereby avoiding detection and destruction by the immune system. Another major part of the immune system is the complement system. It consists of a group of proteins that defend the body by either killing bacteria and other foreign cells directly, or by making those foreign cells easier for the macrophages to identify and ingest. And of course, macrophages are yet another type of immune system cell. The complement system also serves to attract macrophages and neutrophils to the area. Next are the cytokines. These are proteins secreted by cells that act as chemical messengers to mediate the immune response. Finally, remember that all cells, including the cells of the immune system, are primarily composed of protein, as are all tissues of the body. Here's a quick look at the ways cytokines work. They're chemical messengers that provide some instructions. They can act on receptors on the same cell that secreted them, that's called an autocrine function. They can act on nearby cells, that's called a paracrine function. Or they can act on distant cells in other parts of the body, and that's called an endocrine function. This table lists the types of cells of the immune system, all of which, again, are primarily composed of proteins. When the tissues of the body have good integrity, their protein matrix is tight and well organized, leaving no room for pathogens to fester or for tumor cells to gain a foothold. So clearly, protein is absolutely vital to proper immune system functioning. It's well established and documented that protein deficiency leads to impaired immune function. So the point is that structural integrity of the cells and tissues are crucial to overall health. Understanding protein will provide lifelong benefits in terms of health, performance, and appearance. Of course, that's only if you apply that knowledge. Ultimately, learning more about protein helps you to become more aware of how this vital substance impacts the health of your entire body. To review, we covered some important information about proteins, including a brief review of their roles in the endocrine system, the nervous system, and the immune system. Clearly, protein is a complex subject, and there's a lot more to cover. So, in addition to providing more educational videos on the topic, I'm providing a way for you to dive deeper with the Real Protein Report. It's free, so be sure to take advantage of it. If you like this video, hit the button below to share it with friends who might also benefit from it, and please subscribe to my channel for more practical health tips. Thanks for watching. I'll be back with more info in the next video. I'd love for you to connect, stay in touch, and learn more about my mission to make the world a healthier place. Click on the left to subscribe to my channel. Click on the right to see more videos on protein that I've kind of put into a playlist. And be sure to click the link in the description to get your copy of the Real Protein Report. Thanks again for watching.